Okay, so we are back for the coding challenge number 3. As always, let's open our workspace and take a look at the requirements. Okay, so project number 3. Today we are building an important component of our DAO because we are building the token. If we want DAOs to be sustainable organizations, generally there is a token that is either created, or you could also say minted. So mints meaning creating tokens. And generally this token is distributed to community members. It can be traded for other currencies, but it represents the internal economy of the community, internal economy of the DAO. And so our mission today is to implement a token. Keep in mind that we will only implement a simple token. It's not how you would implement a real token. If you want to implement a real token, you would use the ICRC1 standard, which I've linked here if you want to take a look at the ICRC1 standard. In a real world scenario, also the mints and burn function wouldn't be accessible by anyone. So with this token, anyone is going to be able to mint and burn token, which is not necessarily something we want. So keep that in mind. And for the requirements, the token has a name and a symbol. The token has a total supply. Anyone can mint token, anyone can burn tokens, anyone can transfer tokens to another person, assuming they have enough tokens. So that's just a little list of requirements. And then we will use a hash map or a tree map. If you're curious about tree map, you can take a look. Tree map is very similar to hash map, but the underlying representation is different, but the methods are the same. So if you know how to use the hash map, it will be very easy for you to use the tree map. You can use either the hash map or the tree map, and then the rest you will figure out by yourself. It's fairly doable, I would say. Yeah, there is not like a lot of big difficulties here. So good luck. Let's say 25 minutes for this project, and then I'll correct and give you some advice. See you, everyone. Okay. Let's go. I hope it was doable. I hope you've succeeded. Otherwise, let's just correct it. So I can see already there is a question about, can you trade this token? When you want to build a token on the IC, you simply need to create a canister that store balances and manage transfers, essentially. Once you have that, you will notice that a token is nothing more than a hash map where you have principal or accounts that are linked to a specific balance, which will be a natural number. And then you can just trade the token, you can use the token in a wallet, then everything else is just integration on top of the canister. Of course, the canister needs to be black hole, so it means that there is no one controlling it. If there is someone controlling the canister, it means that the token is not it's not safe. I mean, it's safe as long as you trust the person controlling the canister. And usually the DAO that starts the token will be the controller of the canister. Okay, so let's define our ledger. The ledger will store the balances of all the users for our token. So let's ledger. The key will be principal and the value not. And then, as we've already done in the past, it's principal.equal and principal.hash. Let's create a name for our token and a symbol. And then we can implement function 2 and 3. So we shouldn't give it the same name because it's gonna be confusing here. So we can just specify name and symbol. Okay, now let's go for the mint function. This is the task number 4. So we take a principal and an amount, and we will increment the balance of this person by the specific amount that we have here. I will use the option library. So option option is a library that you can use to work with optional values. So we've seen that we can use a switch case, but we can also use this library. And there is a function which can be useful, especially in a situation like this one, which is option.get. So the balance of a user is gonna be option.get ledger.get owner, so the principal here, and 0. Essentially, option.get enables you to specify an optional value and a default value. If the optional value is null, you default to the default value. In my case, if there is not a balance associated with a principal, it means that your balance is actually 0 at the moment. So that way I can receive the balance, and then I can do simply ledger.put owner and then balance plus amount. And whatever the amount is and whatever the balance is, this is correct code. So here, actually, we never return the error, so it's not necessarily the best return type, but it's still correct. Now the burn function, we want to subtract the amount. So this time we will have a specific case, which will be that if the balance is below the amount, we cannot burn the token that we don't have. So the balance is not enough for the amount to burn. Otherwise, we can simply do the same ledger put minus amounts. And so here, this will never be negative because we have verified this condition. Now the transfer function, actually there is a typo here. It should be 5 and 6. Okay, so now that we have the burn done, we can move to the transfer. And this time there is a little bit more check that we need to do. So we have a from principal, a to principal, an amount of token that we want to transfer. And essentially we transfer from this account to this account. So let's balance from is option.get ledger.get from 0. And you've probably guessed it. We will do balance 2. Now, if we don't have enough token, so if we are in the case where the balance from is below the amount, we can return an error. Cannot continue transfer the from. Well, the from account doesn't own enough token. Otherwise, we can continue by doing ledger that puts from balance from minus amount and to balance to minus amount. And then return OK. And that's it for the transfer function. Now let's go to the balance. So the balance is actually fairly simple because we have already used the balance quite a few times in the code already. So we can simply return option.get ledger.get account. Zero. And the total supply. For the total supply, we will need to iterate over our ledger. So let's say total balance is initialized to 0. And then for balance in ledger dot, so we need to iterate over all the values. Let's say the keys, the values. So we need to iterate over the values. Total balance. We add balance to total balance, and then at the end of the for loop, we return the total balance. Now let's deploy. So we are now at project 3 already. our supply is going to be 0, but we can actually create some tokens. So I just need a principal. This one. Let's say 100 token. Okay. Let's say I burn 50 of them. So now my total supply should be 50, and that's what we see. Could also test the transfer, but we would need to have 2 principals. And that's it. It's really not that complex. And that's enough to build a token. It's not the standard, of course. If you want to dive into it, it's slightly more complex, ICRC1. But honestly, yeah, building a token is really not something that is very complex, because it's just storing a balance for every user and then changing the balance as you need, with some check, of course, for like situation where you have not enough token. Oh, actually here, I forgot it was a plus. I know the purpose of the transfer is to transfer to a different account, but if we do transfer from and to the same address, the amount will double inside the account. It should not double because we are subtracting it and then adding it. So it should not double. If you want, you can add a protection. Check that, for example, if from we could do something like this. But wait, I'm not following you. Balance to is initialized before we subtract. So balance from, balance to. So those are our balances before any transfer. So those are the initial balances. Oh yeah, you're right. So this is going to be, no, that's, wait. So let's say we have 50 here. So we also have 50 here, and we transfer 50. If we do that, we pass this check, but then we are going to put, yeah, you're right. I was, yeah, that's totally right. So here, that would be a edge case that I didn't think about, which would be problematic. I guess the best solution would be to have a protection here. Free money. We could already mint token for almost anything. So yeah, but nicely spotted. I didn't get the ledger part. Can you elaborate on the ledger? I'm not sure what you need. What kind of, what didn't you get? But essentially, I was just saying that a ledger is just a canister that contains this type of data structure. So it could be a hash map or tree map, or could be another data structure in Motoko. We've seen the map this morning, and that stores the balances of every single user. So it's not that different from, well, I guess I don't have access to plug here, but you have a token on the IC. So like ICP coin showcase all the tokens that exist on the IC. If you go here, and so all those tokens, they simply implement a similar type of interface. In the case of those canisters, it would be the ICRC1 standard. So yeah. Okay, so that concludes our session number 3, coding session number 3. Good job if you've made it. And we see each other in 15 minutes. We have a next session, mentorship session. I'll also talk about modules and packages in Motoko. We have touched upon it this morning, but I'll say a few words. And goodbye.